This peculiar aircraft is set to take flight soon with a distinctive mission to achieve the utmost quietness. Known as the X-59, this NASA research vehicle also goes by the Quiet Supersonic Technology Demonstrator, or QUEST. Let's delve into how this unconventional jet might pave the way for supersonic airliners, shortening the New York to London flight to a mere 2 hours, faster than the Concorde. Additionally, there could be intriguing military applications for this pioneering technology. Time equates to money, and in aviation, speed equals life. Swift transportation grants more time at your destination for essential tasks. Whether in personal airline travel or military missions, greater speed offers added options in case of contingencies. For airlines, an unofficial speed cap of about 600 miles per hour has been established. Despite technological capabilities surpassing this limit, the average New York to London flight duration remains at 6.5 hours, unchanged for half a century. Notably, the Concorde soared at speeds exceeding 1,300 miles per hour. However, why persist with this speed limit for airliners? Primarily, it boils down to two pivotal factors: efficiency and noise. To propel an aircraft at higher speeds, it needs to generate increased thrust, leading to higher fuel consumption and costs. While more efficient engines and sleeker designs aid, most planes have been fine-tuned to operate at around 600 miles per hour or slightly below the speed of sound. Supersonic flight, indicated by a Mach number where Mach 1 signifies supersonic speed, is presently beyond the norm for today's airliners and business jets, averaging between Mach 0.7 to 0.8. Surprisingly, this speed restraint isn't due to technological barriers but rather noise concerns. When an aircraft breaches the sound barrier, a disruptive shockwave known as a sonic boom reverberates. This noise can be bothersome or unsettling for people on the ground, leading several countries, including the United States, to outlaw civilian aircraft from generating sonic booms over land. However, what if we could diminish these sonic booms or make them nearly imperceptible? NASA's answer to this conundrum is the X-59 QUEST. Understanding how the X-59 addresses this noise issue requires a look at the mechanism behind sonic boom creation. As an aircraft navigates through the atmosphere, it continuously produces pressure waves that radiate from its path. These waves travel at the speed of sound, approximately 678 miles per hour at 30,000 feet, dispersing in all directions akin to ripples caused by a droplet in water. Upon surpassing the sound barrier, these pressure waves amass and compress, creating shock waves, much like how water waves gather ahead of a boat in motion. As an aircraft nears the speed of sound, these shock waves shoot away from it, causing an abrupt shift in pressure. This quick change manifests as a resounding boom or crack, recognized as a sonic boom. Remember the Concorde? Despite cruising at Mach 2 or 1,350 miles per hour, its sonic boom was robust enough to prompt several nations to limit its supersonic flights to just over the ocean. The Concorde, a marvel of engineering and a stunning aerial spectacle, flaunted delta wings and a sleek fuselage. Though operational from 1976 to 2003, its technology shone, but its economics and noise levels didn't match up. Operating costs were sky-high, and its supersonic roar was too disruptive over populated regions. In the pursuit of silent sonic booms restarts through the purpose-built X-59. Its elongated, slender design strategically manages the aircraft's volume and lift distribution, dispersing shock waves to prevent them from forming overpowering sonic booms. Additionally, the X-59 is designed to fly at higher altitudes, around 55,000 feet. Today, most airliners operate between 30,000 and 40,000 feet. This increased distance from the ground also reduces the noise heard from the sonic boom. The X-59 is powered by a modified General Electric F414 GE100 engine, similar to engines found in the Navy Super Hornet, allowing the X-59 to fly at speeds of Mach 1.4 or just above 1,000 miles per hour. While it will fly supersonic, the real question is how loud will it be? You're probably familiar with decibels, which measure sound loudness or intensity. What you may not be familiar with is a metric known as perceived loudness, PL, used in psychoacoustics to measure the subjective perception of sound loudness by a listener. For example, a firework going off 500 feet away would have a PL value of 113.6. The Concorde sonic boom had a PL of 105. The X-59 sonic boom is estimated to have a PL of 75, equivalent to the PL of a car door being slammed across the street. So, the X-59 sonic boom is more of a sonic thump. The X-59, aside from its noise-reducing design, sports a streamlined cockpit obstructing forward vision. To navigate, the pilot relies on an advanced flight vision system with a forward 4K video camera. Imagine the look of these silent supersonic jets. One concept flaunts a lengthened body and adaptable wings, extending for takeoffs and landings, then retracting for supersonic or perhaps hypersonic flight at speeds up to Mach 2.2. Such an aircraft could slash the New York to London journey to 3.5 hours, down from the current 6.5. Achieving Mach 3 speeds could trim it to just 2.5 hours. Despite resolving sound issues with the X-59, there's still the hurdle of efficiency, especially fuel consumption. Flying at Mach 3 or even Mach 2.2 demands significant fuel, possibly leading to higher costs. However, as these designs prove successful and carry more passengers, expenses may drop. While the Concorde attempted this, today's aviation tech might make supersonic commercial travel a reality. What about military applications? At first, a silent sonic boom does not seem crucial in a military context. In a contested environment, noise doesn't matter much. However, the latest push in military aircraft is all about stealth, remaining undetected for as long as possible. Stealth focuses on reducing the radar cross-signature and heat emissions, but sound reduction could be another way for an aircraft to avoid detection. Designing an aircraft with a reduced sonic boom could be advantageous for reconnaissance or strike missions. NASA's X-59 quest represents a unique moment in the adventure that is aviation. Quiet sonic booms or sonic thumps will likely open up possibilities for commercial supersonic overland travel that were once inconceivable and would redefine what we consider as fast travel. Flights from New York to Los Angeles, which currently take about 6 hours, could potentially be completed in less than 3 hours. This incredible speed could revolutionize international and cross-country business, enabling quicker transactions, faster deliveries, and a significant boost in global productivity. It brings new weight to the phrase "speed is life," as the impact of this technology could be truly transformative for a wide range of industries. As the technological development around the X-59 quest continues, there will be many more milestones and breakthroughs to discuss. These may include progress in the testing phases, regulatory developments allowing supersonic flight overland, or perhaps even the first commercial offerings from aviation companies. As each development unfolds, I will continue to chronicle this exciting journey by creating new videos to keep you informed. The evolution of aviation is a compelling narrative, and the X-59 quest is a major chapter in that story. Thanks for watching, everyone. If you liked this video, don't forget to hit the like button below and subscribe. See you in the next video.